Question number 9 of exercise 5.2 that is taken from the Calculus SM Yusuf book. We need to solve this definite integral. The limits of integration are from negative pi by 4 to positive pi by 4, and the function given is 2x cube minus x over x square plus 1 into x minus 1 into x plus 1. Let's suppose this integral is to some equals to some alphabet. Let's just name them equals to I. We know that we can break our limits of integration into two parts. And by breaking the limits of integration into two parts, we can get two integrals out of this one integral. Using theorem 5.8 of your book, that is given on page number 176. Theorem 5.8 says that we can break our limits of integration into two parts such that your interval is from a to b. We can just pick a point out of this interval from a to b, and we can just break this integral into two parts. How? We can break it from a to c and c to b, and that c basically belongs to this interval a to b. So using that theorem, in this question 9, our limits of integration are from minus pi by 4 to pi by 4. I am just taking 0 from this interval. Minus pi by 4 to pi by 4. You can see, like, if I put 0 here, I will get 0 in my function. So this is the breaking point. We can just take this point on which the function is 0. I just split that limit of integration from negative pi by 4 to 0 and 0 to pi by 4 into two parts like this. Negative pi by 4 to 0, and the same function is written as it is, and then plus 0 to pi by 4, and this function is written as it is. Now I am naming these two integrals some other name. Let's suppose the first integral is equals to I1 and the second integral is equals to I2. Consider I1. First of all, I need to solve this I1 separately, because you see here these are the lengthy integrations, so I'm just naming them separately so that I can get back the results easily. Consider this I1 integral here. You see that minus pi by 4 to 0 integration 2x cube minus x over x square plus 1 into x minus 1 into x plus 1. Let's have some substitution here. Let's suppose x equals negative t. I want to make it some kind of function here that will be similar to this second integral I2. For that purpose, let's suppose your x is equals to negative t. Differentiating on both sides, this will give us dx equals to negative dt. Now, if we are changing the variable of integration, we need to change the limits of integration as well. This limit of integration is for the variable x, not for the t. So, we need to change our limits of integration as well. For that purpose, you see here, first of all, the lower limit. When x approaches to negative pi by 4, put in place of negative pi by 4 here, you will get t equals to positive pi by 4. I am using this equation for the limits of integration. When x approaches to pi by 4 will be equals to negative t. So t will be equals to, this is basically negative pi by 4. So when x approaches to negative pi by 4, this will be equals to negative t. So t will be equals to pi by 4 here. So this is my lower limit. Now upper limit. When x approaches to 0, put 0 here, I will get 0 is equals to negative t, so 0 is equals to t. So it means t approaches to 0. So my lower limit here is pi by 4 and the upper limit here is 0. Also replace in place of x negative t like this. 2x cube is 2 into negative t cube, negative negative, x is negative t, x square is negative t square. Here x is negative t and this x is again negative t. And you know that dx is equals to negative dt here. So just replace it with this negative dt. Now simplify all your terms. I will get here, this is the odd power of this t. So negative sign will come outside. So it will be negative 2t cube minus minus plus t. And this will be t square plus 1, negative t minus 1 and negative t plus 1 into negative dt. I can take this negative sign common so that I can just get back the same function here. You see here we have 2x cube minus x here. It is the same thing but with the opposite sign. So if I take the negative sign common, this negative and this negative after multiplication will give us the positive one. So come back to this denominator. From this I can take the negative sign common. I will be left here with t plus 1. If I take the negative sign common from here, I will get t minus 1. Negative and negative will give us the positive 1, and I will get this thing here in my denominator. Now I got pi by 4 to 0, negative 2t cube minus t, negative negative will become the positive, so it will be finished. And also from the denominator, negative will be finished because we have two negative signs here that will be multiplied and give us the positive sign here. Now we see that here it is the same function, 2x cube minus x over x square plus 1 into x minus 1 into x plus 1 dx. It is the same function, but the variable is t here. And the second difference is the limit of integration is from 0 to pi by 4, and it is from pi by 4 to 0. The limit of integration is reversed as compared to this one, opposite to this. We can change the limit of integration sign. How we can change it? We can change it. We know that we can write a to b f of x dx equals to negative b to a f of x dx. We can change this position if we just write negative sign here. So it will be changed. The position of the integration, limits of integration will be changed if I put the negative sign here. And I know that I can change this variable as well without changing any other thing. I can replace, we know that if we have a to b f of x dx, it will be equals to a to b f of t dt as well. So I can just replace this t with x. So it will be dx here. You can use the substitution back as well. You will get back the same thing. But directly you can use this theorem that is given in your theorems portion of this exercise as well. You can just replace them. If you replace them, you will get back the same integral, that is I2. Now you got the answer of I1. Just use this I1 in this equation that you were having previously here. After using this I1 value here, you see both the values are same. I1 and I2 are same, but with opposite sign. So this will be cancelled and we will get 0 in our answer of this question number 9. Question number 10 says, integrate from 0 to pi x sine of x over 1 plus cos square of x dx. We know that we have a theorem, that is theorem 5.9, this theorem that is on page number 176. We know that we can just replace our integration is, if we have the integration from 0 to a f of x dx, we can replace our f of x with a minus x, this upper limit minus x. We can replace this x with upper limit minus x. Both the integrals will have the same answer. So using this theorem 5.9 here in our question number 10, my upper limit is pi. I can replace my x with pi minus x here. So just replacing x with pi minus x, this x with pi minus x, and here in the bottom cos square pi minus x. Now we know that we can open this thing. This is the formula of sine alpha minus beta. This will be equals to sine of alpha cos of beta minus cos of alpha sine of beta. Alpha here is pi, beta is x. After opening this thing, I know that cos of pi will give us the 0 answer. And sine of pi is equals to 1. So 1 into cos x, I will get here, this is sine of pi, here, this one. This sine of pi will be 0. If you use your calculator, you will get the sine of pi equals to 0. Basically, the cos of pi is not 0, it is negative 1. So this negative and negative will give us the positive and sine of x in our answer from this. So I will get sine of x from here. Now I need to open this cos square of pi minus x. You can write this cos square of pi minus x as cos of pi minus x whole square. Now open this formula. This will be cos pi cos x plus sine of pi sine of x here. And you know that sine of pi is 0, so this term will goes to 0, and cos of pi is negative 1.